Alright, ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I'm glad you joined me this evening. Tonight's homework is for the evening of April 27th, 2018, and tonight we're looking at our SOL review, and this is part 3. Let's get started. So again, we have our 5 questions. They could come from any topic, and this first question is one that most of my students are pretty comfortable with. This looks at what is the measure of the angle shown at the right. And here is our protractor. Here is the angle that is shown in our book. So if you notice, this angle actually sits right here, points off to the right. And how do we measure that? Is it 60 degrees or is it 120 degrees? Well, if we look at this section down here at the bottom, our angle always sits on 0. That's the key for this. Our angle always sits on 0. See the close-up? And the inner markings start at 0 and go to 180. The outer, that I've labeled here in red with a red arrow, ends at 180. So which one do we use? We use the inside. We always start with 0 for wherever that angle is actually sitting on the ground. So we're starting at 0 and we're counting up, so we're using the inner markings. And besides that, this is an acute angle. If this was a 120 degree angle, then this would look like an obtuse angle. So all of our reasoning says that this is 60 degrees. And that's actually the answer. The answer here is B, 60 degrees. Alright, moving on to the next one. Which of the following best describes the translation from point A to point A prime? Remember that A with the apostrophe is pronounced A prime. And point A is our starting position, A prime is our ending position. So let's take a look at this. Here's our coordinate plane. Here's our starting point, A. So let's see, we move up 1, 2, 3, 4, 5. So we moved up 5. Or positive 5, and we move 1, 2, 3, 4, 5, 6. And we move over 6 to the left, and that would be negative 6. So that's our ending position here. That's A prime, that dark green circle. And if we use our translation notation, left 6 units, 5 units up, that's negative 6, positive 5. And the best answer for this is H. The best answer is H. All right, moving on. Number 3, the table shows the number of hours worked by Malcolm. Which of the following is the independent variable? Well, if we look at just the heading for the table, you all know from your science class and your math class, and possibly real life if you've worked a job, that the number of hours you work determines what you actually earn in an hourly job. And I've worked a lot of different hourly jobs, and yes, that is the case. So using our reasoning and knowing that math depends on relationships, we know that the general relationship between hours worked and earnings is that the earnings increase based on the number of hours you work. And the answer is D. I'm going to go ahead and prove that the number of hours worked is our independent variable. If you look at this table, the thing they did to try to throw you off was to put the hours worked out of order from least to greatest. They're not in order. So if you sort this table from least to greatest and make sure your earnings remain matched up with the hours worked, you end up with this chart. This is the corrected chart that shows 18, then 20 hours, and 21 hours, and 25 hours. And you see the earnings that you get from each, from each X value, because that's what you're looking at. It's a table with X and Y. If you wanted to, you might be able to figure out a function. We don't need to do that with this particular problem, but we know the independent variable, the X, is our hours worked, D. Moving on to the next one. The state tree of Virginia is the American dogwood. It grows to up to 50 feet, which is least likely to be the height of an American dogwood. Now, if you are looking at this set of answers, F is 8, G is 10, H is 14, J is 17, you might look at this and go, I'll just pick the one that's furthest away from 50, and I'll pick 8. If you do that, you'd be wrong. Here's why. If you look very carefully, and again, in other words, of these choices, the way you read this problem, which of these heights is the least likely to be seen if you just happen to be looking at trees and you're looking at American dogwood trees? Which of those 4 choices is the least likely height for one of those trees? And what they try to do here to throw you off is in the problem they give you feet, but in the answer they give you meters. Okay, so that's where the issue in this problem would be. Your strategy here is to convert the height in the problem to meters, and in a problem like this they will have to give you a formula sheet, so there's going to be some kind of conversion factor. I looked this up on Google, and Google knows everything, and so 1 meter is 3.28084 feet, and we figured this out from our homework last night. So it came up to, show up in another problem. What we have to do with this is divide 50 feet divided by 3.28084 equals 15.23. So if you have that in a proportion, and I didn't work the proportion out, it's 1 divided by 3.28084 equals x over 50. Meters on the top, feet at the bottom. All right, we know now that problem says the state tree can grow up to 15.23 meters. What are you probably not going to see? How do you interpret that piece of it? Is the answer still 8? No. When you look at this 50 feet or that 15 meters is the outlier for the data set in what they describe in the growth of American dogwood trees. So in other words, when they built this question, they said, okay, the tallest tree we see is 15.23 meters. That's the tallest. It grows up to that height. So the least likely possibility is 17 meters. You're not going to see that because it's past the tallest tree that they describe in the problem. This one's sneaky, but the answer is J, 17 meters. The answer is 17 meters. All right, going on to number 5. Kurt and Nancy hiked 3.2 kilometers east and then 1.9 kilometers north. What's the closest to their final distance from the campsite? Which answer is closest to the final distance from the campsite? And let's look at this. Ooh, that's a familiar shape. 3.2 kilometers east and 1.9 kilometers north. Guess what? This is a right triangle. And as always, well, most of the time, we're looking for C. We're looking for the hypotenuse. This is the Pythagorean theorem. So here's our ABC, 3.2, 1.9, and C. And it doesn't matter what you call A and B. We just plug in our numbers and solve. 3.2 squared plus 1.9 squared equals C squared. 10.24 plus 3.61 equals C squared. 13.85 equals C squared, and you find the square root of both sides. 3.72 equals C. And that is the right answer for this. The answer is going to be B. B as in boy. All right. One last thing. When you all are solving these and you're at this step where you're trying to figure out C squared, I see some students dividing by 2 right here. There's a big difference between dividing by 2 and finding the square root. Right here, you have to find the square root. That's how you solve for C squared. So keep that in mind. Make sure you're careful about how you do your math, and you should be just fine. That's it. Y'all take care, and remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.